Great. So starting off here, tells us that our table gives us some information on the percentage of people in the United States who played video games on their mobile phones in the years since 2010. Use a graphing calculator to analyze the data. All right, so we're going to go ahead and get our graphing calculators open and head to it. This is kind of nice because it actually reminds you in here how to make this work. So what I'd like you to do is get into your graphing calculators and start typing in the information. I'm going to take attendance. I'll go ahead and load up all this information here. So let's see, stat, edit. If there's anything on your list, just make sure you go to the top of the list and then hit clear and enter. So highlight the actual list and then hit clear and enter. We're going 1 through 10. Oops, not here though. Okay. So there's our info. From here, we want to be able to view the information. So a couple things need to happen first. So once you have your information typed into your L1 and L2, head to the Y equals menu. Make sure that if there's any equations written in there that you clear those out. So clear that out. Make sure that plot 1 is highlighted in black. That way it'll be actually, you'll be able to see the points. And then we need to go ahead and it's also going to tell you here, actually, you know what? This is a good idea. Let's go make sure that your stat diagnostics are on. These directions are a little bit weird. Just go to mode right up next to second. If you click on mode, scroll down to where it says stat diagnostics. If it's off, move it over to on and hit enter. So hit mode, scroll down to stat diagnostics. If on is not selected in black, scroll over to it, hit enter. That'll make sure you're good to go there. All right. Once you have that and your list of information, we're going to make a scatter plot. So head to the window button now, because you should have all your information typed in. So just hit window up next to Y equals. Hit window. And it tells us right here, it actually gives us the information of the window settings we should have. Let's go ahead and make that happen. So the minimum X value is 0, the maximum X value is 12, and we're going by ones. The minimum Y value is 0, the maximum Y value is 100, and we're going up by tens. If you hit graph from there, it should look exactly like what's on inside your book. So that's what we got. Cool. All right, now this particular function is we're going to use our logarithmic to deal with this today. And I'm trying to think here because I feel like, well, let's see. What is that? 6, 10. Yeah. All right. Cool. So It says, from the scatter plot, the data appear to have a curved trend that approximates a natural logarithmic function. So basically, if you were to type in ln(x), it would have that kind of shape to it. So what we're going to end up doing is we are going to calculate a logarithmic regression. Right here, determine the function of best fit. So we're going to head back to stat. We've done this kind of thing a lot of times. We're going to scroll over to calc. Now, the first thing I want to do before we do our logarithmic regression, the other option here would be potentially, what would be our other potential type of graph here? If it ends up looking like that. Exponential doesn't really, I mean, exponential could do that, right? If it ended up having a, like if you have an inverted exponential regression, because if you do this and you flip it over the x-axis, it would look like that. So if we check out an exponential regression here, so go to xreg option 0, and if you hit calculate, it's going to give you an equation. However, the r squared value is 0.87. So the correlation coefficient here is the 0.87 for r squared, which is not a super strong correlation. Like, it's okay, but it's not super solid. And if we test out a logarithmic regression, head back to stat, go to calc, scroll down to option 9, lnreg, that's a natural logarithm regression. You can go ahead and check out that. And when you hit enter here, calculate, our r squared value shoots up to 0.9867. So we're looking at about almost a 99% logarithmic regression correlation coefficient, which is much stronger than 0.87. So it is definitely more logarithmic than it is exponential. So this is a good equation for us. So then what we're going to do, now that we have this information, we've got our equation right here. And this equation is actually saved in our calculators. And so we can actually look at what this particular function is. Now, it says the function is this. We're going to actually be able to calculate it more accurately than that, because we're just going to import the function as opposed to typing in the function on our y equals menu. Either way, though, I want you to go to your y equals menu. So head to y equals. And we're going to import that function that our calculator just got for us. And so we're going to push this button here that says vars. Right underneath the down arrow on the directional pad, hit vars. Scroll down to option number 5, statistics. Hit enter. Scroll over to EQ for equation. And then reg EQ is the regression equation that our calculator has saved, which is that logarithmic one. So if you hit enter, it's just going to automatically import that function with a lot more decimals than what's here in our book right into the y equals line on our calculators. And then you can hit the graph button, and you can see that the natural logarithmic function follows those points very, very close, which is great. So from there, it says you can use the table generated. We're going to go to our table of values here in a second. It says you can use the table generated by the graphing calculator to predict the percentage of people who play games on their phones in a given year. Go to the table and use the arrows to scroll down to x equals 15 to predict the percentage of people who will play games in 2025. Why would x equals 15 represent the year 2025? What's that? Yeah, our value, our starting value was 2010. So years since 2010, 15 years since 2010 would be 2025. So an x value of 15 means the year 2025. So if we head to our table of values, so second, hit the graph button, that will give us our table. Scroll down to 15. And we get 71.384. That's the percentage of people who would be expected to play games on their phone in 2025, next year. So about 71% of people, in 2025, about 71.4% of people in America will play games on a phone. Cool. All right. The last thing we're going to talk about is to figure out the different conditions that we have on our graph here. Now, if we look at the function itself, we've only gone down to 0 on the x-axis and the y-axis, but if we zoom out a little bit, just zoom out right here. And I'm going to zoom back in, but I'm going to zoom in right around here. Okay. So you can definitely see that the y values go into the negatives. However, here, it says that the range is y is greater than 0. But we can clearly see on our graph that the y values go below 0. Why is there that discrepancy? X is greater than 0 makes pretty good sense because x will never actually equal 0. That's where that vertical asymptote ends up being. So with that vertical asymptote, values of x will never actually equal 0. But why does this say that y is greater than 0 when the graph clearly goes under the x-axis into the negative on the y-axis? You need to think about that for a second. Because technically speaking, the y values go down forever, and because it's logarithmic, they also go up forever. So it should be all real numbers based on the graph. However, we're saying according to what we have that it's going to be greater than 0. In fact, I would argue that it's not just greater than 0. I would say that this is the range. I would say that that's the range. Y is greater than 0, but also less than or equal to 100. As opposed to what the function here on the graph shows is all real numbers for the y values. Why am I limiting this? All right. What do the y values represent? What's that? Percentage of people. So why then would I be limiting the y values to greater than 0 and less than or equal to 100? 100% of people, there's no such thing as more than that, okay? And then why does it have to be more than 0? There's not less than 0 people, right? Negative percentage of people doesn't make sense. Neither does more than 100% of people. Because 100% of people is all of the people, right? Can't have more than that. So because there is context here, right? If it was just a function, like if all we had was this, then yeah, the range would be all real numbers because there's nothing attached to it. But there's a scenario here. X is years since 2010. So that can go on indefinitely, right? Years will continue to go on no matter what. There's no limit to that. That's why all of our X values are greater than 0. Years since 2010, that'll keep going. However, percentage of people, you've got a very limited range there. It's between 0 and 100, no matter what, in terms of percent of people. We have an x-intercept here. We could figure that out just doing a calculation. Remember, if you go to your calculation menu and then go to 0, that will tell you where it crosses the x-axis, which is at about 0.2687. There is no y-intercept because it'll never cross the y-axis. It'll get infinitely close to it, but it'll never actually cross it. The graph is increasing on the y-axis when x is greater than 0. Okay. Now, there are negative values on the function between 0 and 0.2687. However, according to our scenario, negative should be the word none, right? There shouldn't be anything in the negatives here because we're talking about years and we're talking about people, like percentage population. So negative time, negative population percentage, neither of those makes any sense. I would argue that this should say none if we're sticking to the context of the problem. The end behavior. As x goes to positive infinity, y also goes to positive infinity. That is true for the function. Just knowing that it can't go above 100 in terms of the reality of the situation. So it says and even down here, it says this particular function includes y values less than 0. However, in the context of the situation, y represents a percent of population and therefore must be positive, as well as being no more than 100%. Cool. All right, that's all I got for it. We got about a half hour left. So